Welcome to the DIY Honda Garage channel. The DTC P0238 signifies an issue with the turbocharger boost sensor circuit, indicating that the output voltage from the turbocharger boost sensor is higher than acceptable limits. This DTC is a diagnostic trouble code that can trigger a series of warning lights or messages in the instrument cluster. The malfunction is detected by the Powertrain Control Module, PCM, which monitors voltage inputs from various sensors, including the turbocharger boost sensor. If it senses an abnormal value, it flags this code for further diagnosis. In the Honda CR-V 2023 Plus, the turbocharger boost sensor is crucial for controlling the engine's boost pressure, directly influencing performance and emissions. Failure to diagnose and repair this fault could lead to significant engine inefficiency and potential long-term damage. The turbocharger boost sensor plays a vital role in managing the air pressure fed into the engine, thereby ensuring optimal performance and efficiency. Located near the turbocharger, its main function is to measure turbo boost pressure and send that data back to the Powertrain Control Module, PCM, for proper engine management. If the sensor outputs a voltage that exceeds predetermined thresholds, the PCM interprets this as a fault and triggers the DTC P0238. The affected components in this context are the turbocharger boost sensor itself, the external circuitry that connects it to the PCM, and the PCM that processes the incoming data. Recognizing the precise location of the sensor is essential for troubleshooting, as it facilitates access for inspection and replacement if necessary. The circuit diagram is often referenced during troubleshooting to understand the pathways of data and power that are crucial to functionality. A few possible causes of the DTC P0238 include a faulty turbocharger boost sensor, which may result from wear and tear or internal failure of the sensor itself. Additionally, damaged wiring or connectors associated with the turbocharger boost sensor could lead to short circuits or open circuits, disturbing the voltage signal. This wiring, including any ground connections such as the SG2 line, should be thoroughly checked. Furthermore, a malfunction in the PCM could erroneously interpret the signals, leading to incorrect voltage readings being communicated. Conducting a detailed inspection of these components helps in identifying the root cause of the DTC and aids in effective troubleshooting. Understanding these potential causes simplifies the diagnostic process and guides technicians in taking appropriate corrective measures. Symptoms commonly associated with the DTC P0238 may include increased exhaust emissions due to improper air-fuel mixture as a result of incorrect readings from the turbocharger boost sensor. Drivers may also experience reduced engine performance, indicated by sluggish acceleration or hesitation during operation. Additionally, it's common for the engine warning light to illuminate, serving as an alert to the driver that there is a fault that needs addressing. These symptoms can significantly impact the overall drivability of the Honda CR-V and could cause extensive damage if left unresolved. Identifying these indicators early on aids in timely repairs, preventing more serious complications down the road. For the first troubleshooting step, begin by turning the vehicle to the on mode without starting the engine. This allows for the proper activation of the vehicle's systems and diagnostic capabilities without the interference of engine operations. Following this, use the Honda Diagnostics System, HDS, to assess the output voltage from the turbocharger boost sensor. It is essential to check that the HDS reading for the TC boost pressure sensor is no more than 4.49 volts. If it exceeds this value, it confirms a failure condition which will necessitate further investigation into electrical issues or component failure. Accurately reading HDS values is a key step because it allows technicians to narrow down the fault directly at the sensor level before moving on to diagnosing wiring or PCM issues. In the second step of troubleshooting, first, ensure that the turbocharger boost sensor connector is disconnected. This is a critical safety measure before proceeding. Next, you will need to jump terminals number 1 and number 2 of the sensor's connector using a jumper wire. With the terminals jumped, turn the vehicle to the on mode once again. At this point, confirm through the HDS that the TC boost pressure sensor voltage is now less than 4.49 volts. Receipt of this normal output confirms that the sensor itself may be malfunctioning and not providing accurate readings under normal operating conditions. This method isolates the sensor and checks its response correctly, laying the groundwork for determining if it requires replacement. For this step, the focus is on inspecting the wiring and connections leading to the turbocharger boost sensor. Begin by first disconnecting the PCM connector and then using the HDS to jump the SCS line while waiting for over 1 minute. This preparation is crucial to ensure that you get accurate readings during the inspection. After ensuring everything is secure, you'll need to verify that there is less than 1 ohm between the terminals of the open wire inspection for 2 points, the P3 and the ground line SG2. Any reading beyond this threshold signifies an issue within the circuit, which could contribute to the high voltage reading observed. Carrying out this methodical inspection supports an accurate diagnosis of potential wiring defects that could be causing signal disruption. The final step involves analyzing the results from the previous inspections to make a sound judgment about the condition of the PCM. If all other inspection items yielded normal conditions, this often indicates that the issue may reside within the PCM itself. It is essential to have a well-functioning PCM for optimal functionality of the engine management system, as it processes signals from multiple sensors to ensure the engine runs efficiently. If the PCM is determined to be at fault, this could necessitate a replacement to rectify the DTC P0238 issue. Understanding how to diagnose PCM conditions enhances the overall troubleshooting capability and can prevent unnecessary component replacements. In the final repair verification process, begin by using the Honda Diagnostic System, HDS, to clear the DTC from the PCM. This resets any fault codes that had previously been recorded and allows for a fresh assessment of the system. Following this, it is recommended to take the vehicle on a test drive under normal driving conditions. During the test drive, monitor the performance and exhaust emissions closely. Look for any reoccurrence of warning lights or DTCs. A successful end to this testing confirms that any repairs undertaken have effectively resolved the issue. This verification step ensures that both the performance and the efficiency of the engine have been restored, making it a critical part of the overall troubleshooting procedure. Preventive maintenance is essential in avoiding issues related to the turbocharger boost sensor and its circuit. Regularly inspect the turbocharger boost sensor and associated wiring for any signs of wear or damage. This proactive measure can help catch potential issues before they lead to serious DTCs like P0238. Additionally, ensuring the integrity of the wiring and connectors is crucial, as even minor frays can lead to voltage discrepancies. Furthermore, keeping the PCM software updated can mitigate risks related to misinterpretation of signals, which is vital for preventing DTC occurrences. Establishing and following a routine maintenance schedule contributes significantly to the longevity and efficient operation of the Honda CR-V. In conclusion, DTC P0238 highlights an essential issue in the turbocharger boost sensor circuit, indicating a potential malfunction that could significantly impact vehicle performance. A systematic approach to troubleshooting, which includes thorough inspections of relevant components and connections, is crucial for accurate diagnosis. Understanding the functions of the turbocharger boost sensor, external circuitry, and the PCM is vital for effective repair. Following the diagnostic steps outlined ensures that any faults are accurately identified and resolved. It's also essential to adopt preventive maintenance practices to avert reoccurring DTCs, thereby ensuring the vehicle remains in optimal condition. Please like and subscribe to the channel. See you next time.